Today we're going to be looking at numerical measures. So last week on Thursday we looked at tables and graphs, right? That we can use in order to summarize data. Okay, today is going to be actually a little more of a productive day because in stats these are the type of techniques we use most often. Okay, we do present data with bar graphs and so on, but we also use numerical measures. Right? So we're going to look at different aspects of a data set, and that's described in our outline. So we're going to start with measures of center, right? Typical values, what I call their center tendency. Then we're going to look at measures of dispersion, how spread out the data set is. These are the same issues that we looked at last time, right? But now instead of graphs and tables, we're using formulas, basically. Okay? Then we're going to look at measures of how variables are related. Okay, so those three are that's the core of today's discussion. Okay, topics 1, 2, and 3. Then we get into this thing called the z-score. Now, the z-score is a small little formula that is probably the most important formula in this whole course. Okay, it's a very simple formula, right? So you should be able to remember it. Although on the exam you can bring a list of formulas, a cheat sheet, right? So you can write it down, but that one topic, the z-score, maybe the single most important discussion we're going to have is also a very short one because we're going to revisit it again in chapter 6, then in chapter 7, and then 8, then 9, then 10. Basically, after the midterm, we're going to be seeing the z-score every single day here. Okay, so we're going to spend some time on that. It's very important that we understand what the z-score is within the context of the empirical rule. And at the very end, we're going to look at percentiles and quartiles. So there is one concept or topic that I will not cover in this chapter, just like I dropped one concept last week, right? So once we get to it, because I can't remember exactly what it was, but I'll notice that once we get to it, I'll let you know. All right? So let's start with a very with our first bullet point, right? Which is measures of center tendency. So the whole point of this set of techniques that we're going to see here, there are 4 here, right? You can see them listed in green. We're going to look at the mean or average, the median, the mode, and the weighted average, or weighted mean. So we're going to look at 4 techniques. And the whole point of this set of techniques is to measure the central tendency of the data set, meaning what is a typical value within the data set. So what's typical, right? In terms of a frequency distribution or a histogram that we looked at last week, where is the center of the distribution, right? Because in the center of the distribution is where we get the typical values, right? Now there are different ways of measuring center, of measuring what's typical. Okay, and each of them have their own advantages and disadvantages, right? So we're going to look at 4 different ones. Although you could just say 3 because the last one, the weighted mean, is just a different, it's the general form of what an average is. Okay, so it's really 3 main ones. What's an average? What's the median? And what's the mode? How many of you have seen this before? Well, I'm not going to ask about the average. I'm talking about the median and the mode. You've seen it. Okay, so this should be a simple discussion, right? But I will focus more on the notation part of it, because that's what I think throws some people off, okay? The notation in the formulas, because computing an average, we know how to do it, right? So we'll do one of those, right? So start with that. Now, the average or the mean is the most popular, the most widely used type of measure of central tendency. So out of the 3 that I just showed you, average, median, and mode, the average is the most popular one. And there are statistical reasons for that we won't get into here, right? You may probably see that in a second course. This book doesn't really cover it. At least we won't cover it in this course. So it's beyond the scope of the course to talk about the statistical properties of the average. But the reason why the average is such a popular measure of center is because of its statistical properties. Okay? All right. So how do we compute the average? We have a data set with X number of or n, I should say, n number of observations, you add them up and you divide it by n, right? Where n, we said last time, was the size of the data set, okay? The number of observations in the data set. All right, so that's, so now let's look at the notation. We're going to work on an example in a minute, okay? But the notation is what's important here, because in the future, when we get to more challenging areas of statistics, and I'm referring really to post-midterm stuff, we're going to use this notation, right? So I'm going to assume that you already know it, okay? Do you guys understand how that formula in the green box is built? When you look at it, can you read it? Or is it a little confusing? All right, the big sigma means what? Summation, right? So this thing here, sigma, stands for the summation of whatever is inside the sigma, right? In this case of x. So this means we're going to add up all the x values. That's all it means. Okay? We're going to sum across the x values. All right? Now, why do we have this little I index? Well, that's an index variable. Okay? And all we're saying is that I, which is here also, I starts at 1. That's what that means, right? I equals 1 means I starts at 1 and goes all the way to n. Now, once we work on an example, this will be very, very straightforward. Okay, but let's say that n, what's n again? Is the size of the data set, right? How many observations, how many data points we have in the data set. So let's say that n is 5. That means we have 5 observations, right? So how many data points we have? 5 of them. Okay? 1, 2, 3, 4, 5. So I starts at 1 and goes all the way to 5. You can see it here. Let me get my you can see it here, right? We're basically saying there is the first data value, there's a second data value, there's a third, there's a fourth, there's a fifth, and so on, right? Up to n. Okay, that's what I means. This means that it's an index variable, and it starts at 1 and it ends at n. N could be anything, depending on the data set. So all this means here is just add up the values up here and divide it by the count, right? The number of values. That's all it means. But I'm not so concerned about you being able to compute an average, because you can do that, right? I'm more concerned about you being able to read that, that green box, that green formula. Okay, so anybody not comfortable with it? Anybody has any questions about it? Let's look at an example, okay? I'll get back to this other formula in a minute. All right, look, we have a sample of size n. There's another point that I need to make that is actually very important here. So I'm not focusing on how to compute an average again, right? I'm focusing on other things, right? Okay, so there's a sample of size n. N equals 5 in this case. And there are 5 data values, so let's look at them, right? 7.1, 4.8, 9.0, 3.3. These are your 5 values. Now, why am I writing them out this way? Because I want to go back to the notation that we just looked at. Okay, you can call this one x1, x2, x3, x4, and x5, right? Basically, you're saying you have a column here of data, right? You have a that you're going to call xi, right? That basically means this is your x variable, okay? This is your x variable because it varies from observation to observation. How many do you have? You have n of them, right? N of observations. In this case, 5. So I equals 1, then I equals 3. That's all it is, right? So the formula says take all these x values, add them up, right? Where I starts at 1 and it ends at 5 in this case, right? And then once you add them up to get the average, divided by n, which is 5 in this case. Done. Okay? All right, now there's one other thing I want to make sure, and the average is just 6.08. So there's one other thing that I want to make sure we get from this. And that's that this formula here, and again, this is notation again. This formula here, it's the formula for the sample average. Do we know the difference between a sample and a population? Alex, yeah.
Well, the sample is just a portion of the population.
Yeah, a subset, right, of the population. Okay, so if your population has 20 people in it, right, your sample has to have less than 20, like 4 or 5. 6, 7. Okay? Now that formula is the formula for the sample average. So this notation, when you say X bar, when I say X bar later today and in future days, I'm referring to specifically the sample mean, not the population mean. Okay? X bar is the sample mean. Why? Because n is this, where is it? Is the sample size. Okay? So all this notation here, and this, I'm referring to two things specifically, X bar and n. Those are that's sample notation. Okay? X bar is the sample mean, small n is the sample size. Is that all right? So how does it change when we go to the population? What if we were dealing with all 20 people, right? The entire population. The formula changes, the structure of the formula is the same, right? But the notation changes. Do you see where? If you look at the structure, what are you doing? You're adding up, you're summing across all x's, just like before, right? And then you're dividing by n, just like before. So the population mean is the same. But the notation is different to make sure that we understand that this is not just a sample estimate. This is the actual population value. Okay, and there's a significant difference between the two. So what is mu? That's mu, right? The Greek letter, mu. So population notation is usually in the form of Greek letters. Okay? Mu, that's going to be your population mean, population average. Okay? And instead of using small n, you use uppercase n to denote what? The population size. So what are we saying then? Which one is greater? Michelle? Which one is greater, this one or this one? Or which one should be greater?
The capital one?
Yeah. That has to be the case always, right? If we're saying that a sample is a sample, it is what it is, right? Which is a subset of the population, then the sample size should be smaller than the population size. So if this is 5, then the population size should be 6 or 20 or 100 million. The point is this, that whatever computations you from the sample only is an estimate of what you're really looking for, which is the population value. Okay? So, in other words, X bar is really an estimate of mu. There are two very similar things, yet they're very different, right? In the sense that the way they're computed is the same, right? How do you compute X bar? Take all sample values, add them up, divided by small n, right? How do you compute mu? Take all the values in the population, add them up, and divide it by big N. It's the same thing, right? Computationally, it's the same thing. But in terms of the concepts, they're very different. They're very different things, right? This is going to be an estimate of this thing. Okay, so going back to my day 1 example, if this is the average age, if mu is the average age of all US citizens, average income I use, right? Do I use age or income? Income. Okay, so per capita income, right? I don't know what that would be, what, like 40,000, let's say. 30,000, I don't really know. Okay, so the average income of US citizens, right? Let's say that's 40,000. Okay, X bar is going to be an estimate of that 40,000, right? Because it's going to come from a subset of, let's say, 2,000 people, right? So when you survey 2,000 people and you get the average of that small group, you most likely will not get exactly 40,000, right? So maybe you get less than 40,000 as your average, or you get more than 40,000 as your average. But that's only an estimate of the actual average. Is that all right? So this is really what you're looking for. That's the actual average of the entire population. And this is just an estimate of mu. Okay? Which brings, could bring into the discussion many other issues, but we'll skip it for now because all we're doing is just estimating, computing these numbers. All right. So what's a weighted mean? A weighted mean is how I'm going to compute your grade. Exactly how I'm going to. So you're going to have to compute your own grade when you want to forecast. What do I need to get on the final exam, right? To get an A in this class. You're going to have to do weighted mean computations. A weighted mean is just it's an average, but where different observations are given different weights for whatever reason, right? For example, going back to your grade example. If I think that the final exam should be worth more, should contribute more towards your average grade than the homework grade, right? Then I have to use weights when I compute the average. And that's exactly what I do, right? If you look at the core syllabus, what is the weight for the final exam? Do you guys remember? Because I don't. 40? 40. And the midterm, I think, is 30, right? That should be right. So basically, I am basically saying that the final exam is the most relevant item, grading item for this class with a 40% weight. Okay? Then the midterm with 30%, then the homework with 10, then the quiz with 10, and then the CEC with 10. Right? That's going to add up to 100%. Usually weights are expressed as percentages, usually, but that's not always the case. Right? So what is this new thing? When you look at the formula is actually very similar, right? We're using sample notation. Do you see that X bar? The formula is similar. What we've added here is this thing called WI. Okay? And down here, instead of dividing by n, we divide by the sum of the weights. Okay? Now, usually, what I was just saying earlier is that when you use weights that are percentages, right, and they add up to 100%, like I do for your average grade, right? I could just, instead of saying 100%, I could say 1. They add up to 1, right? Then usually the denominator is going to be always 1. If the weights are in decimals, in percentages, right, like 20% and 30% and 40%, usually, typically, the weights add up to 1. So you just don't divide, because dividing by 1 is just not doing anything. Is that all right? So we'll look at an example in which the weights don't actually add up to 1. Okay, but most of the time they do. All right. So let's look at an example here. This is a more complex example than I would like it to be. But what do we have in that box? What do we call that? Frequency distribution, right? That's what we looked at last week, Thursday. Frequency distribution. So the number of days worked. So this is 1 week is one observation, right? So I don't know, week 1 you maybe worked 3 days. On week 2 you maybe worked 6 days. Okay, it looks like you never worked 7 days in a week, right? And you never worked less than 3. So what are the possible classes? The possible number of days worked. You've worked either 3, 4, 5, or 6 days. All right. How many weeks are we looking at? How many data values are we looking at? Let's look at the table, right? So this means what? 4 of the weeks, you worked 3 days. 7 of those weeks, you worked 4 days, right? And 3 of those weeks, you worked 6 days, a lot. Okay? Now, there's 2 ways you can answer that question of how many different weeks are we looking at. You can add up these frequencies, right? And they give you 20, and you can just read it here. Okay? Basically, we have a data set of 20 weeks, and we're looking at each week how many days of the week we worked. Is that all right? Now, what if I want to know what is the average number of days that I worked during this sample of 20 weeks, right? What is the average number of days that I worked during this sample of 20 weeks? In this case, I have to use a weighted mean. Does that make sense? Do you see why you have to use a weighted mean? Let's say we don't use a weighted mean. What would be the alternative? To just add up these numbers, right? Number of days worked. Add up the numbers and divide it by 4. Right? Yes.
Well, we have to use a weighted mean because there's more the frequency is larger for some than others, so you're not giving proper allocation.
Exactly. Right? So there are more weeks, in which we worked 4 days than weeks in which we worked 6 days. Right? So we can use those frequencies as actual weights. Okay? Because some of those values, some of those classes, some of those categories are more relevant in the sense that they have a bigger weight, right? They have a higher frequency in this case. So to get the average number of days worked, what we need to do is we need to actually use those frequencies as weights. Okay? And that's straightforward. Same table, and that's the formula. Now look at what we have. Let's look at the first row. We have the case in which we worked only 3 days, right? The weight for that is 4. So we have 4, that's the weight, right? 3 is the actual data point, right? 3 days. So that's W times X for the first row. How many rows do we have? 4. Is that okay? Plus the second row, which is going to be 7, that's the weight, times 4, and so on. So we take the weight, which is in red, and we multiply it times the number, which is in blue. Then we divide it by the sum of the weights, right? Which in this case is just a total number of observations, right? It's going to be 20, okay, the sum of the weights. So 4.4. Now, if we didn't do that, right? If we actually just took the average without worrying about the weight, so if we just looked at the blue numbers and we ignored the red numbers, what would have been the average? If you just add them up, right? 7, 12, 18, right? 4.5. That would have been the average. If we ignore the frequencies, 4.5 would have been the average. Why do we get 4.4? Why do we get a lower average than 4.5? Because 4 has such a higher, much higher frequency than, let's say, 6, right? So that gives 4 a higher weight. Therefore, it's going to have a higher contribution towards the average. So you're basically pulling the average down in a way, right? The weighted average is lower than the actual average. Okay? Now, like I said, a better example is going to be some sort of a grading system. So let's look at that. Let's say that these are your grades. X1 is going to be your homework grade, okay? That's X1, homework. Quiz grade, that's X2. How many do we have in this class? 3, right? Grade 3 is the CEC for the class. Then you have the final exam. Let's start with the midterm. And the final exam. All right, these are your grades for the entire course, right? Now, before we can compute your average grade for the course, we need to do what? We need to know what are the weights, because they are not equally weighted, right? So what are the weights? We know the weights. It's going to be 10%, 0.1, 10%, 10%, 0.3, 0.4. Notice that in this case, the weights add up to what? It's easier to work with weights that add up to what? Right? To 1. How do we get the average grade for the course? Multiply across, right? So first get xi times wi, right? So it's going to be 0.9, 0.7. Am I saying this right? No, sorry. 9, 7, 10. Now you got to help me with this one. 24 and 40, right? That's the grade multiplied times the weight. So what do you do now? You add them up. So it's 40, 64, 74, 81, 90. 90. How do you get the average grade for the course? You take the sum of the product and you divide it by the sum of the weight. So in this case, the sum of the weights is just 1. So your average grade is just 90. 90 divided by 1. Okay? I think that's enough about the weighted mean. All right, so a few conceptual issues. What is the advantage of the mean? One thing is very simple to compute, right? And the other one is that it takes the whole data set, right? And it's going to give you a single numerical value as a summary of it. So there is no 2 values or there is no graph or table. You get one number that tells you about the center of the data set, what's typical as the average or the weighted average, okay? What is the problem with the mean? And these are things that we want to really remember, okay? The main disadvantage of I would say, the second one is the main disadvantage, but you can argue, right? It's debatable. The main disadvantage of a mean, the average, is that it's sensitive to outliers. Remember when we said what our outliers were? What are outliers, even though the definition is there? Outliers are going to be extreme values, right? Values that are very different from what? From what's typical. Okay? So let's say that you have, let's say, going back to the example of grades, right? You guys take the midterm exam, and all the numbers are very close. Everybody gets, let's say, 85, 86, 84, 80, 81, 89, 90, right? Everybody's around a B, A minus, okay? So out of 16 people, 15 people have sort of like a B, B plus, A minus, right? Everybody's in that range. But there's one person that just did very poorly and got a 20 or a 10. What's going to happen to the average? Is it going to reflect a B minus? No. The average is going to be pulled down, right? Because this outlier brings the average down. Now, it's going to show like a typical value was a C plus, let's say, when it really wasn't, right? It was just that one value pulled the average down in my example. Does that make sense? So when you have outliers, the mean is going to suffer in the sense that it may be misleading as a measure of center, right? The center may be somewhere else, but this outlier is bringing it lower than what it should be. Okay? That's one disadvantage. The other one is obvious, right? Which is that you lose the original data because when you compute the average, all you get is one value, which is a summary, right? And you lose the original data. See, when we use tables and graphs, you see more information because you see different bars or slices in a pie chart, so you have more data. In this case, you just have a single number, right? So the example here is you can have your data could be 999, 1,000, 101, and your average is 1,000. Your data could be 0, 1,000, and 2,000, and your average is the same thing. So these data sets are very different, right? But they have the same typical value. Okay? So unless you look at the actual data set, you don't know, the only thing you know is what's the center, but you don't know anything else. Right? So one thing we know is that in this case, in sample 1, the data is much more clustered together, right? In sample 2, the data is much more spread out. Okay? But there are other things that we're going to look at later today that measure how spread out the data is. Okay? So in this case, sample 1 and sample 2 have the same mean, but they have different measures of variation. Okay? All right. Okay, let's practice using our clickers. This could be potentially the easiest problem I'm going to give you all semester. So if you can compute the mean while who needs a clicker? Should be working today. Sarah, you need one? Thank you. Weighted mean, yeah. I don't think I opened it yet. Give me 1 second. Okay, it's open now. So as soon as you are done with your computation, if you just click on the number, it should register it. I'm not really sure if it's really working yet. Yeah, it's working. I got one response. If you change your mind, just click the new number, right? And it would override it. And I guess I should tell you that the first weight applies to the first observation, right? So 0.4 is the weight for the observation 3, the data value 3. The weights add up to what in this case? I hope they add up to 1. Yeah, they do, right? So you just divide by 1, basically. Okay. All right, so I have 5 people with response. Yes, 3 is the answer. So I guess whoever answered got it. Right? Let me move on. All right, the median. So what's the median? Let me change the slide so you don't read it. What's the median? The median is a value in the data set so that at least 50% of the observations are less than that value. At least, right? It could be a little more. So in this case, they're just saying, they're being really, the definition is very simple. But we'll actually go back to the median at the very end of today's class. But the median is a value in a data set. Okay, just don't forget that part, right? You have a data set with 20 numbers. The median is going to be one of those. Okay, or there are some exceptions, but the median is going to be one of those values in the data set. Okay, so that half of the observations, that's 50% of the observations, right, are lower than that value. Therefore, half are higher. Okay, so how do you compute the median? Now, why do I tell you, why did I repeat this idea of it's a value in the data set? Because some people confuse the median with what's called the position index or the index point. There are two different things, all right? The index point is just a number that helps you find the median. All right, so let's go through the steps. First, you take the data, and you rearrange the data from smallest to largest. Okay? So you start with the smallest value in the data set, and you move to the right. You write them out from smallest to largest. Then you compute the index point. All right? The index point is going to be 0.5 times n. What is n? The sample size, basically the number of observations. Now notice how 0.5, you could rewrite it, and I know this looks silly right now, but you could, instead of 0.5, I'd rather you think of it as this. 50 divided by 100 times n. That's small n. That looks weird. Same thing. All right. That's the same thing, right? 50 divided by 100 is 0.5? Yes? Now, there's a reason why I'm writing it that way. Okay? Because once we look at percentiles, then we can use the same thing or something similar to this. All right? So whether you look at it this way or that way, that works. It's the same thing, 50 divided by 100. Okay? So take 50 divided by 100 times the sample size. That's going to be the position of, that's going to be where the median is located. Okay? So for example, if this comes out to be, I think it's better if we go through an example. Right? Now, there's something I should tell you. So, okay, let me finish. So you find the index point. That's going to be some sort of number like 7 or whatever, right? And then you go to the data set and you start counting from left to right, from the smallest to the highest, right? You count. That's the first one, second one, third one, until you get to your index point. Okay? And once you get there, there's an extra step we got to take, right? So let me talk about this extra step right now. This number could be a whole number or not. Do you agree? You could get anything from here. You could get a whole number or not. Okay? So let's say that from here you get 6.1. What do you do with this number? How can you go to your data set and start counting? 1, 2, 3, 4, 5, 6. That's not 6.1, right? It's 6. So what do you do with this number? Yeah.
You go, like, if it's 6.1, you go to the sixth number in the order, and then you go to the right, and like look at the number to the right of that, and then you take the average of that.
No. Oh, no. But I know what you're talking about. It's the other case. Okay? So I'm giving you an example here in which what? You compute the index point, right? And the index point is not a whole number. Okay? When the index point is not a whole number, what you need to do is round up. Always. Just round up. I use this number on purpose, right? 6.1, you would think, well, I have to round down. No, you don't. Okay? You have to round up. Always round up. Is that all right? Okay, so what would this be then? 7. Now, you go to your data set and start counting. 1, 2, 3, 4, 5, 6, 7. That's your median. Okay? How is that? That's case number 1. Case number 1. Case number 2 is a case in which you actually get a whole number, which probably won't happen that often. Okay, well, it may happen. Let's say you get 6. What do you do now? Do you round up? Can you even round up? No, right? Do you just look for number for the 6th data value? Nope. I know it would be so simple and nice, right? It would be. If you get a whole number, what you need to do is go and find the 6th value, okay? But then you also need to find the next one up. That's what Alex was saying, okay? If you get a whole number as your index point, you have to go find that value, the 6th one, but then you need to find also the next one in the list, which is the 7th, right, in this case. And you compute the midpoint of these two. Now, the way this looks, it may be a little misleading, so I'm going to have to do an example, right? You go to the data set and you find the value in the 6th position, right? You extract that. Then you go find the value in the next position, in the 7th. You extract that. You have 2 values now, right? Get the average of those 2. In this case, average, midpoint, same thing. Is that all right? So in this case, in case number 2, the value that you're going to end up with as the median is actually not in the data set because it's the midpoint of 2 of the values, right? Okay? But in the first case, you're going to end up with a value actually in the data set. So if this wasn't clear, let's go through an example, okay? Look at this example here. We have how many values in the data set? Sarah, how many? 7, right? Are they already arranged in ascending order or not yet? They are. Good. So that's the tedious part of the work, believe me, right? You got this unless you use Excel, right? And then you just sort really quickly, okay? But if you're doing it by hand and I give you 10 observations, but then it just takes time to figure it out. All right. So you have that's step 1. Step 2 is what? Find the index point. So what you do is you take 0.5 times the sample size, which is 7, and you get 3.5. What do you do in this case? Round up. This is the easy case, the one with the least amount of work. You round up and what do you get? 4. Now, the last step is go to the data set and find the 4th value. 1, 2, 3, 4. 28, that's your median. Okay? Now, I'm going to give you one of the multiple choice answers and you're going to pick that one. And that's not the median, right? What's 4? 4 is the location of the median. Where is the median located within the data set? Right, in the 4th position, right? That's not the median itself. The median is the value located there. Is that all right? So the median is not 4. The median is 28. So I'm repeating that because that's where, I know that's where you guys make a mistake, okay? So the index number, the index position, is just an intermediate step in finding the median, okay? But this is an easy case, right? That circle is wrong. So I have the highlighted number, but they're wrong. That's awesome. Sorry. Too late to change it, right? So I'll just leave it. But that's wrong, okay? Let's look at let's look at the other case. Look at this case. What happened here? What is our sample size? 6. We have values arranged, right? So what we just looked at was case 1, right? Now we're looking at an example of case 2. So the values are arranged from smallest to largest. We compute the index number, which is half of the sample size, right? And that's 3. What do we do now? We go to the data set and we find the 3rd number. Then we go to the data set and we find what else? The 4th number. So we extract these 2 here. Basically, we're looking for the 2 middle numbers, basically, right? 170 and 182. What do we do with them? Midpoint, the average of the 2. So it's going to be 170 plus 182 divided by 2, 176. That's your median. Okay? Is that good? Now notice one thing. In the first example, the median was actually a value listed. In this example, the median is not a value listed, right? Because 176 is not on this data set. But that's fine. That's still the median. Okay? Now let's go here to talk about one of the main advantages of the of the median. And it's right there, you see it, right? The median is not sensitive to outliers. Now look at what changed. Look at this data set, right? It starts at 21, 27, 27, 28, blah, blah, right? And it goes to this last number. This number is obviously an outlier. Do you agree? All the numbers are around 20, 40, 30. And this thing is 5,000. Okay, that's an outlier. Now, if you look at this data set, it's the same data set, but instead of 5,000, we have 50, right? What's the median in this case? 28, we said, right? The median here is 28. If I change the 50 for 5,000, that means if I create an outlier, does the median change? No. So the median is not sensitive to outliers. Okay? Is the mean sensitive to outliers? Would the average change? Of course. It will be much larger than what it should be, sort of, right? Remember, what is the idea here? The idea is to understand what is a typical value, right? In this data set, what is a typical value? Is it 3,000? No. A typical value is around 30, right? But if you have this outlier, it's going to bring the mean all the way up to 3,000. It's going to really be misleading, right? But the median would not be misleading. Okay? That's why, a typical example of cases in which people report usually the average as a measure of central tendency, but sometimes people report the median. And an example of a case in which they always do is when we're looking at property prices, real estate. And you can figure out why, right? Because maybe all houses around the area are 300,000, 400,000, 200,000. But then there is 2-3 houses that are 20 million, right? So reporting the average there is really misleading, okay? To know what a typical house price is in that area. All right. Good. The mode. So you see do you see what is the main advantage of the median over the mean? The sensitivity to outliers. There is very little sensitivity, okay? So whenever you have outliers, you want to report both, right? You want to report the median and the mean, okay? Whenever you don't have outliers, both numbers will probably be very similar. All right, the mode is what? Is the value with the highest frequency in the data set, okay? The value that you see most often in the data set. Okay, so usually when you construct the frequency distribution, you can pick up the mode right away, right? Okay, but now the mode works best with qualitative data. Okay, with qualitative data. So that's the main advantage of using the mode. That with qualitative data in which you cannot add it up, right? You cannot divide it by anything, right? It's qualitative data. If you still want to know what the central point is, what the typical value is in the data set, the mode is better. Or is best. It's the only one you can actually use. The problem is what? That you may have a data set with no mode. Then it's useless because there is no mode, right? When would that be the case? Well, a data set in which none of the values gets repeated, right? Then there's no mode. Or you may have a data set in which you have two modes, two values with the same frequency. Now it loses meaning, right? Unless the values are close to each other, it loses meaning. Okay? Or three modes, right? So definitely, unless you're dealing with qualitative data, the mode is the least popular one. All right. So in this case, we have numerical data. So you have a data set. This is your data. It's already obviously arranged from smallest to largest, right? You have a bunch of zeros, a bunch of 1s, 2s, and 3s, and 4s, and only one 5. The number that gets repeated the most, that is found the most often, is 5, right? It's there 8 times. So that's your mode. Okay, and you can look at it here too. It's nicer, right? It's pretty straightforward. Okay. Now this is a way of just showing you the same. We talked about the mode when we looked at chapter 2, right? And we looked at frequency distributions and bar graphs or histograms. Okay, so this example covers all 3, except for the weighted mean. We don't have a weighted mean here because there are no weights, right? But it covers all 3 measures. We have the average. You know, we have a data set with house prices, and how many are there? 5. So you have 5 house prices. They add up to 3 million. So what is the average price? 600,000, right? 3 million divided by 5. What is the median? Well, you gotta arrange your data from smallest to largest and go through the entire set of steps, right? 300,000. Is that right? All right. So once we get to it, because I can't remember exactly what it was, but I'll notice that once we get to it, I'll let you know. All right. So let's start with a very with our first bullet point, right? Which is measures of center tendency. So the whole point of this set of techniques that we're going to see here, there are 4 here, right? You can see them listed in green. We're going to look at the mean or average, the median, the mode, and the weighted average or weighted mean. So we're going to look at 4 techniques. And the whole point of this set of techniques is to measure the central tendency of the data set, meaning what is a typical value within the data set. So what's typical, right? In terms of a frequency distribution or a histogram that we looked at last week, where is the center of the distribution, right? Because in the center of the distribution is where we get the typical value. Median and mode, the average is the most popular one. And there are statistical reasons for that we won't get into here, right? You may probably see that in a second course. This book doesn't really cover it. At least we won't cover it in this course. So it's beyond the scope of the course to talk about the statistical properties of the average. But the reason why the average is such a popular measure of center is because of its statistical properties. Okay? All right. So how do we compute the average? We have a data set with X number of, or N, I should say, N number of observations. You add them up and you divide it by N, right? Where N, we said last time, was the size of the data set. Okay, the number of observations in the data set. All right, so that's so now let's look at the notation. We're going to work on an example in a minute. Okay, but the notation is what's important here, because in the future, when we get to more challenging areas of statistics, and I'm referring really to post-midterms, z-score. Now, the z-score is a small little formula that is probably the most important formula in this whole course. Okay, it's a very simple formula, right? So you should be able to remember it, although on the exam you can bring a list of formulas, a cheat sheet, right? So you can write it down. But that one topic, the z-score, maybe the single most important discussion we're going to have is also a very short one, because we're going to revisit it again in chapter 6, then in chapter 7, and then 8, then 9, then 10. Basically, after the midterm, we're going to be seeing the z-score every single day here. Okay? So we're going to spend some time on that. It's very important that we understand what the z-score is within the context of the empirical rule. And at the very end, we're going to look at percentiles and quartiles. So there is one concept or topic that I will not cover in this chapter, just like I dropped one concept last week, right? So today we're going to be looking at numerical measures. So last week on Thursday, we looked at tables and graphs, right, that we can use in order to summarize data. Okay, today it's going to be actually a little more of a productive day, because in stats, these are the type of techniques we use most often. Okay, we do present data with bar graphs and so on, but we also use numerical measures. Right? So we're going to look at different aspects of a data set, and that's described in our outline. So we're going to start with measures of center, right? Typical values, what I call their center tendency. Then we're going to look at measures of dispersion, how spread out the data set is. These are the same issues that we looked at last time, right? But now instead of graphs and tables, we're using formulas, basically. Okay? Then we're going to look at measures of how variables are related. Okay? So those three that's the core of today's discussion. Okay? Topics 1, 2, and 3. Then we get into this thing called the values, right? Now there are different ways of measuring center, of measuring what's typical. Okay? And each of them have their own advantages and disadvantages, right? So we're going to look at 4 different ones. Although you could just say 3, because the last one, the weighted mean, is just a different, it's the general form of what an average is. Okay, so it's really three main ones. What's an average? What's the median? And what's the mode? How many of you have seen this before? Well, I'm not going to ask about the average. I'm talking about the median and the mode. You've seen it. Okay. So this should be a simple discussion, right? But I will focus more on the notation part of it, because that's what I think throws some people off. Okay. The notation in the formulas, because computing an average, we know how to do it, right? So we'll do one of those, right? So start with that. Now, the average or the mean is the most popular, the most widely used type of measure of central tendency. So out of the three that I just showed you, average,